Hello everyone. Today I'm going to discuss about a problem that we face on a day-to-day basis when working with large servers with huge resources. And to tackle that problem, we are going to use Kubernetes. What we what we have is large amount of servers with huge resources such as CPU, GPU, RAM and storage, and we have a lot of users. But the thing is, how are we gonna give users some amount of resources according to their requirements that can change time to time, and also manage resources such that every user has some kind of resource to work on while not a single user hogging all the resources. So based on this will be our solution would be JupyterHub notebooks per users, and we will be deploying containers via Kubernetes. So let's look into it. So okay, we have three nodes. This is our one node, exact 10887. This is also called beast. There are two lambdas. This is lambda 1 and this is lambda 2. Let's see their system OS, what system we are working on. So this is a Ubuntu 24 machine. This is a Ubuntu 22, and this is also Ubuntu 22. Also, let's look at our CPU. We have around 32 cores. We have around 47 CPUs here, and the same number here. Let's see our memory. We have 1 terabyte in this beast. We have around 66 gigs here. Also 66 gigs here. Now let's see our GPU resources. We have around 8 of these 80 A100. We have 2 times 10 gigs of GPU here in one lambda, and 2 times 10 gigs of GPU in another lambda. Finally, let's see our storage. So for the beast, we can see, let's focus on this. We will be using our network storage NAS, and you can see it's mounted at cell NAS, and we have the same setting here as well. We have mounted the same thing here and the same thing here. We are going to use network storage because we want to, even if we change the nodes based on our computing requirements, we would having the same resources, so we won't be creating different version or different volumes multiple times. So this is why we are utilizing NAS. Now let's go and see our configuration. Okay, let's first see our pods that are already running. So here you can see NFS pod is there, Nginx ingress is there, because we would not be using port forwarding, and this is a better approach in my opinion. And we have Jupyter pods for 2 users right now running. We have Flannel for networking. We have core DNS, etc, AP supervisor, and we have proxies here, and we are using NVIDIA for GPUs. We also have a dashboard to monitor the health of our nodes and the users activity. Also we have Metal LB for load balancing. Let's see our config. So we will be checking every 15 minutes and if for more than 4 hours users are not doing any activity, we'll be freeing up the resources for that user so other user can use it. Also, we can see there are admin users. We have the option to allow multiple servers for each users, but I don't think we require that because they can hog all the resources, but there is an option, we can change that. Also, we don't give option for people to just go into the URL or IP and sign up new users, and sign up allowed is false. Okay, and we have a SQLite database for maintaining our passwords and all the settings. Also, we have, if we want to add new users, we have to change this whitelist here. Currently there are 4 users. If you want more users, we have to add it here. And we need to add what profiles or what computing resources we are going to use them. Let's say, for example, test user, we are just giving one profile. It will have a lambda GPU, just one GPU. For user 1, we have 3 profiles, no GPU, tiny GPU, and A100. For user 2 and user 8, you can see the same things almost. So this is our profiles. You can see the CPU, memory, storage, and GPU condition there. There is a toleration in our lambdas and not for our A100, because if you give toleration for lambda here, that means only lambda node would be hosting this profile, and since we have 2 lambdas and one A100, we can just give toleration to 2 lambdas and we can have A100 free to use. Since A100 is also the control pin, we'll be having multiple pods that doesn't require GPU but still need a node. So yeah, you can see different kind of configuration for CPU, memory, storage, and GPUs. Now going into here, this is our display name spawner list. Okay, this is our code, and you can see our host. We have 3 hosts. If we are on a local network inside the VPN, we can access the service via JupyterHub 2.local, jupyter.sail, or just by the IP, which is 10, we can see later. So yeah, I'm going to just give jupyter.sail to our members in the lab, and HTTPS false, cluster IPs, this is the normal, storage is NFS 200 gigs. So yeah, this is it. Also, let's see our ingress file. Here you can see our IP 10.105.10.200. If we are just use that, we can still use our service. Now there are all the backups that we have done. Let's go through some commands. I don't know if will be useful or not. So okay, no, we don't need this. Okay, these are the commands to create backup if we want to change any configuration. And to change password, it's a bit difficult. We have, because it's not just because admin user has the capability of just deleting users, and since that user is already in the config file, the user can go into the login screen and create a new password, but in doing so they would lose their previous storage files. Hence there is a bit of involvement. We have to delete some persistent volume claims and persistent volume claims, and we have to pass those and do a lot of things. So there are some commands for that here. Okay, now let's see the demo for that. So right now, as you can see, I am inside my LAN, so I have access I am inside my LAN, but so I can access via this IP. I should be. If I go here, I was already logged in. Let's see. If I'm not logged in, I will be getting this screen. So let's do again 10 and 200. So I'll be getting this screen, and let's say I use this and I have my, let's say I give random password. It shouldn't, yeah, invalid. And if I do random username, random password, it shouldn't be. Okay, so this is whitelisted username and we have a password that I have checked. So it will give this, but this is not the first thing that you would see. Let's stop my server right now and start my server. So this is the first thing that you will see when you log in, and there are a lot of profile, and we can choose which user have access to what kind of profiles. I have to all of this. So let's try no GPU for now. Start, and let's see, we have this notebook here, and let's check NVIDIA SMI. We don't have a SMI GPU, and since you can see it is 80%, 938, it's lambda 1. You can see this right now. Okay, let's try stop my server. Start my server. Since I had no GPU previously, let's try 1 GPU lambda start. Again it gave lambda 1. I had seen here. Okay, the same file. As you can see, we have 1 lambda already. Let's not do this again. Let's control stop my server, start my server, and let's try A100 dual GPU. Not just one, let's try 2 GPU right now. But also it's on a different node, and you can see the beauty of the NAS. We have the same file here, we are not changing it, and we can see the storage 80 gigs, 2 of those. And if you do TFDH, you can see, yes, it is our beast. And yeah, we have this, you can see. And let's now log out. And wait a minute, let's go to control panel, and you can see the admin panel here. If we go to admin panel, you can see there are 2 users right now, Agarwal and user 1. We can edit user, we can delete user, we can add users. This is the power given to admin user right now. Let's log out. Let's use user 1, and we have password. Let's see. This is the one, and we have, this is a different notebook, as you can see, because there were previously 3 of those. I created the same name, so yeah, no worries. Let's see. Let's change our profile. Stop my profile. Let's see what profile that user have access to. This is user 1, right? So let's see for user 1 what profile we have. User 1 has no GPU, tiny, and A100 dual GPU, right? So it has access to dual, but let's see if does it have access to quadro. Let's try this. Start. Spawn failed. Try it again. Doesn't give you. What about 1? It doesn't even give you 1. But 2? Yep, it seems to be giving that. And let's see the same thing. Yep, 2, DFH, everything working fine. Okay, also you can see this is also an admin user, but we won't be having multiple admin user. Stop my server. Let's try okay, log out. Let's try a different user, user 2. This user is in the config file, but this is, let's say this is a new user that has already been in config file, but we have not created any password. We can create any password we like. Sign in. it will give the access. And this is user 2, right? So let's see what user 2 have. It doesn't have access to A100. Nope. And so on, and you can see there is no admin as well. So this is our one end of the demo, but let's do a bit more. Okay, this is our beast, and if I do Google Chrome here, we can, since I'm doing port forwarding, not SSH forwarding, not port forwarding, sorry, SSH forwarding, I can have the Chrome browser from that in my local device. And if I do just Jupyter.sail, this is our domain, we'll get the same thing. It's just that instead of the IP, we have now Jupyter.sail. To use that, we can either change our etc host file in every client devices and use this to have that IP. Else, what we can do is in our local network, we can have a DNS to resolve this network name to that IP, and thing works. Else we have the IP, it works anyways. So let's not use this right now. Also, now finally, what we have is okay, our dashboards. So dashboard is running as we have seen in this parts. There are different dashboards running. So how do we assess that? To assess that, we can just go to there are two commands that would be needing, requiring, and we can look that in our not our GitHub, this in official Kubernetes dashboard GitHub, and there it is, how to assess dashboard. So we have to do a port forward, copy that command, come here, paste it. So you have port forwarded that, and the next one is localhost 8443, copy link address. And yes, this right now can only be seen within the beast, I think. So yeah, and we require a bearer token, right? And do you have command for bearer token? We don't have right here, but the thing is, I have put the code here in our GitHub as well. This is our GitHub repo, and you can see dashboard, admin account, install the dashboard, and we can create the token. We require a token, and we can just go to our terminal, come here, create a token. Oh, not dashboard admin, so it is dashboard user, I guess. So yeah, I think I could sense that. I will sense that. It's just a dashboard user, and if we go to here, paste our token, sign in, we would be seeing everything. So we have one node running on lambda 2, one pods running on lambda 2. How many nodes we have? So we have lambda 2, lambda 1, exact rate, capacities, everything you can see here. So, and also workloads, let's see all namespaces. So you can see how many deployments are there, how many daemon sets are there, how many pods are there. So we can see everything, our health of our system from here. And there are a lot of, let's close this right now, guide and I would say troubleshooting that could be done if some error occurs. Yeah, I also required to mention that this service requires swap on, swap off. So we are doing swap off on all these nodes because for some reason Kubernetes doesn't want swap. And as per my research, it says that for since if we have swap, we don't have a clear estimate of our resources, so Kubernetes requires swap to be off. Maybe it is changing and changed in coming versions, but it's still in beta phase or something, I think. And another thing, if I may have, is we have kubectl running, everything is there. I don't think we have anything else, so we can just log in, create users, and yep, I think that's it. So if you have any questions, please reach out to me. And this would be my GitHub page, and you can find all LinkedIn profile here, you can find my mail, everything here. You can just reach out and I'll be happy to talk and help in any kind. So yeah, that's it. Thank you, have a great one.